Hello guys, happy Labor Day weekend. Some of you guys are watching this during weekend. That's totally fine. Or maybe Labor Day or Tuesday, September 9. That's totally fine. This is a pre-recorded video and then we are going to go over transformation, which was 1.1 one more time because we will have a unit test very soon, and then I know a lot of people struggle with the transformations. So let's just review these examples again. Vocabs, please write down because during the test, you are going to see some vocabs, 4 vocab question on the test. So make sure you have this vocab or definitions on your notebook. Since it's not live lesson, you don't have to submit your notebook, but you guys can use your notebook during the unit test. So please write down something that you have to write down. So y-intercept is basically where a straight line meets y-axis of the graph. Linear equation is the equation that makes a straight line. Transformation is another way to say changing the shape of image or graph by either turning, flipping, sliding, or resizing. So please pause the video and then have these things down. Let's go over Desmos. I told you you can use Desmos, which is graphing calculator. You can simply copy or type this link. Let's open it and let's see some transformation example. So here you guys can type f of x or y, that's same thing. And I just put x. This is your parent linear function. The most basic, simplest linear equation is y equal to x. This is your parent functions. If I do x plus 2, for example, x plus 2, you see that shift a little bit, right? The blue one is our new function, x plus 2. What if I subtract? Then it shifts down. So you guys can play with the Desmos, or I can do these things too. 3 times x. Then do you see the purple one? If I multiply with some kind of big number, bigger than 1, your slope becomes steeper. If I multiply with the fractions or decimals, let's do 1 over 2x, then compared to original functions, my slope became less steeper or flatter. I can also do f of x equals to negative x. Then you see it just flipped. Compared to the original, if I multiply with a negative number, I have the reflections. We reflect our graph. So you guys can use Desmos during the test, or you guys can just play with it. That's totally fine. So let's go over some example. I screenshot for you just in case. So the parent function, if we add or subtract, we go up and down. If we multiply, it's a steeper or less steeper. So all this. So everything that we just observed is transformation rules. So here's the table. You guys don't have to copy this because you might have it. Otherwise, a screenshot or make another copy in your math notebook. That's totally fine. So we are not really focusing in stretch or compression in this unit because we have linear functions. Okay, but we will do it again in next module. So please just review vertical shift, horizontal shift, and reflections for now, okay? Let's go over some example. Okay, you might see this on the module 1 test. So if you want, please write down. That's totally fine. You guys can use your notes during the test. So question number 1, write a linear function whose graph is a shift down 3 units, shift down. I go to the table. Translate down means I'm subtracting some number. This is my k, by the way. So if my parent function was x, if I go down by 3 units, it will be just x minus 3. Boom. Second one, compare the graph of g of x equals to x plus 6 with graph of f of x equals to x. This is my parent functions. And then I have plus 6. Whenever we have additions, it's either translate up, right? And then translate left, nothing else. So let's read the first one. The graph of g of x translates 6 units up. Okay, you don't even have to read something else. 6 units up, we're adding plus 6. All these examples are talking about wider or narrow. It means vertical shift vertical stretch or compressions. So they're talking about your slope. Okay, so nothing to do with adding or subtracting number. Next one, explain how the following two functions would compare to each other. So function 1 is y equal to 4x plus 2. Function 2 is 4x minus 1. So in this case, we just have to go through our choices. First one says function 1 is twice large as function 2. Whenever you say twice, whenever they're talking about the size, we are basically comparing the slope. And in this case, my slope, 4x and 4x, they are same, which means this one is not correct answer. Okay. Next one, function 2 moved up 3 units from the function 1. Let's just do this. So my function 1 was 4x plus 2. To make it easy, I'll just put 1 and 2. Okay. Moved up 3 units means what? We're adding 3. And then if you simplify this, you will have 4x plus 5. And that's different than my 4x minus 1, which means this one is not the answer either. Let's do the third one. Function 2 moved up 1 unit from the function 1. Again, my y1 was 4x plus 2. I moved 1 unit up, plus 1. So I have a 4x plus 3. Are they same? Function 2 and the new functions? Nope, it's not same, which means this is not the correct answer either. So let's do our last choice. Function 2 moved 3 units down from function 1. So my function 1 was 4x plus 2. If I move 3 units down, I have to subtract 3. Let's simplify. I get 4x minus 1. And finally, this one is the same as my function 2. So yep, that's our answer. Okay. Let's do a couple more problems. G of x be the indicated transformation of f of x. Write the rule for g of x. So f of x was 3x plus 1. This is our parent functions. And then we have to translate 2 units right. So when I go to the table, I have to translate 2 units right. So I'm going to highlight this one, right? Whenever we are doing horizontal shift, we have to either subtract or add number. And then when you observe this table, when we translate to the right, we have to subtract this number h. H is given. This is your h. And look at the rule. F of x becomes what? F of x minus h. So f of x becomes f x minus, and how much is my h? It's a 2. Okay. Equals to, now we have to find out these new functions. It might be easier for you to understand now because we did the composite functions. So I copy everything down, 3, and then put the parentheses around the x, and then copy everything down. So now you have x minus 2 instead of x. I substitute x minus 2. And then you distribute 3x minus 6 plus 1. Let's simplify. So it will be 3x minus 5. That's your new functions after transformations. So that's it. Whenever you translate right or left, it's a little bit more complex than up and down because you have to put this number inside of parentheses. So that's only difference. Last problem, write a function that is reflected over the x-axis. Parent function is this one. Okay, reflect over x-axis. We're using this. Okay, so my f of x, parent function was 5x minus 8, right? And then when we reflect over the x, all we have to do is multiplying with negative numbers, see? If I multiply negative here, you have to multiply negative here too. Make sure you put the parentheses always. And then you distribute the negative numbers, so it will be negative 5x plus 8. Simple. We just multiply everything with negative. Number 2, use function notation to explain the following transformation of f of x. Vertical compressions by factor of 1 over 10. Vertical compressions, all you have to do is multiplying this factor in front of your functions. So this is your a, okay? This is your a. So we should have a times f of x, right? How much is my a? 1 over 10. That's it. They're just asking for this rule, vertical compression. A times the functions. So 1 over 10 times f of x. That's it. Okay, so I just went over some questions from the test. So please review this. What do you have to do today or until Tuesday? Submit your previous math notebook, August 31st, September 3rd. I also extended 1.3 practice and the lesson quiz due date. Those are due Wednesday, which is September 9 by 11:59 p.m. And the Wednesday, I still don't see you. Please watch another pre-record video and then do the Wednesday assignments. Okay, and then this Wednesday, you guys will have 2 multiple choice problem on Liddell equation. So after you watch the video, I'll put the link. You just click and then submit your assignments. That's it. Okay, hopefully you guys have a really great Labor Day weekend and I'll see you guys on Thursday. Okay, bye.